Hello, everyone. Welcome back. Good afternoon. I am Steve.
And I am Scott.
Together, we're Backyard Musings broadcasting live. I'm in the People's Republic of California, Apple Valley.
And I'm in Utah, at least for one more day. So, guys, have a great one for you today. This is kind of eerie, actually.
Yeah. So, what you can see on your screen is it's this planet, a hidden planet that was detected by a new method, and they think it might be a habitable. It's in a habitable zone, and it's a bigger than Earth. Let's talk about it. A new detection method reveals a potentially habitable super Earth. The breakthrough boosts the search for life supporting planets. Are we alone? This
Mm.
enduring question has fascinated humanity for generations. The discovery in 1995 of the first exoplanet orbiting a star similar to our sun marked a pivotal moment in addressing that mystery. This research was presented in the journal Nature Astronomy on June 3rd, 2025. Would you like to know more?
Since then, exoplanet research has become a central focus of modern astronomy, offering critical insights into how planets form, evolve, and possibly support life. A major objective in this field is finding Earth like life, which hinges on locating planets with Earth like conditions in the habitable zones of sun like stars.
In their search for Earth like worlds, an international team led by the Yunnan Observatories of the Chinese Academy of Sciences, in collaboration with other institutions, made a significant breakthrough using a method called Transit timing variation. For the first time, TTV enabled the detection of a super Earth named Kepler 725c, which is about 10 times the mass of Earth and orbits within the habitable zone of the sun like star Kepler 725. So C would be the third planet from the sun.
Okay. Traditionally, astronomers have used the transit method and radial velocity measurements to detect low mass planets, 10 Earth masses or less, within the habitable zones of Earth like stars. However, these smaller planets usually follow long orbits and produce weak RV signals, making them difficult to detect. The RV technique, in particular, demands extremely precise measurements, which limits its practicality for identifying such faint, distant planets.
So if this is 10 times the size, how come they're not referring to it as a jovial planet, like a Jupiter size planet? Because it's in the habitable zone? Is that why?
I don't know, but that is a big planet.
Yeah.
So um, I don't know. That could, yeah, that again, it's very large. So
Yeah.
what are we what are we doing here? We should be positioning a telescope, getting another space telescope out there to where we can see this thing, right?
Send out a probe so in 30 years we can get some
Yeah.
data from it.
So my grandkids can figure it out. Yep.
Yeah. The transit method faces its own challenges due to geometric limitations. It only works when a planet's orbit aligns perfectly with the observer's line of sight, a condition that is uncommon for planets with long orbital periods. Even when these alignments occur, the dim and brief light changes they cause are often too subtle to be confidently identified, leading to a high chance of missing potential discoveries.
Kepler 725c, the newly discovered transiting planet, orbits a G9V host star with an orbital period of 207.5 days and semi-major axis of geez, 0.674. What is that? What is AU?
Astronomical unit.
Of course. It receives roughly 1.4 times the solar radiation that Earth does. During part of its orbit, the planet lies within the host star's habitable zone, making it a potential candidate for habitability.
Okay, the key here was during part of its orbit. So when it's out of orbit, that means it's colder. When it's
Yep.
in that orbit, it's warmer.
Yep. So you got to figure that, you got to find that Palm Springs time, right? It's not too hot, not too cold. And then,
Yeah, but what I'm saying is like for 3, 4 months, you're cold. and then for 3, 4, 5, 6 months you're hot, and then the rest you're just right.
Just exactly, just right. So that's when you're going to vacation there.
Yeah, if you could survive the radiation and survive the freezing, and wait it out for that just right moment.
Yep.
By analyzing the TTV signals of Kepler 725b, a gas giant planet with a 39.5-day orbit in the same system, this is the second planet. That's a pretty short orbit, too. The team successfully inferred the mass and orbital parameters of the hidden planet Kepler 725c, demonstrating the potential of the TTV technique to detect low-mass planets in habitable zones of sun-like stars.
Unlike the transit and RV methods, the TTV technique does not require the planet's orbit to be edge on or rely on high precision RV measurements of the host star. This makes the TTV technique particularly well suited for detecting small, long period, non transiting habitable planets that are otherwise difficult to discover using these other two methods. Thus, the TTV method fills a critical gap among current detection techniques, providing a promising alternative for discovering Earth 2.0, unquote.
Based on the results of this study, once the European Plato mission and Chinese ET mission are operational, Chinese ET, the TTV method is expected to greatly enhance the ability to detect a second Earth. Okay.
All right.
I like it.
Hey, if you're out there on one of these Kepler 725 planets,
watching this broadcast,
let us know. Yeah, we'd love to hear from you.
And try and speak English if you can.
Yeah, exactly.
All right, folks. Thanks for joining us.
Take care, everyone. We'll see you on the next one.